Everyone who has Home Assistant or some kind of a smart home is always looking for an easy and nice way to display the information. Today we'll be looking at one device, this eInk or ePaper screen, that can help you display statistical information about your home, family, upcoming tasks, and of course weather information. We'll start in a couple of seconds. The topic of this video, or the device in this video that we will be covering today, is this eInk or ePaper screen from Lilygo, the Chinese company that I've previously featured on this channel in a couple of projects. The biggest one of them, of course, was their plant sensor. But today we are not going to be collecting data. We could potentially, instead we'll be displaying it. This all-in-one device that features eInk 4.7 inch display also has a ESP32 module on it, and that makes it nicely hackable for our DIY IoT projects. There are two versions of this board. One that has 18650 battery holder, where you can tuck in the 18650 lithium-ion battery and power the project that way. Or the second option is to go with this PH 2.0 battery holder or battery connector that I'm using myself. But I will also mention one additional thing that I will not be covering in this video, and that is a possible upgrade to this device. And that is, of course, adding the touchscreen possibility or option to use touchscreen. As I mentioned, I will not be showing you how you can program the board with that because I'm still playing with it. But if you go with the previous display and this touch panel here, you will be able to use them together and have a nice ePaper display with touchscreen capabilities. So where to start? On the stream a couple of weeks ago, we played with this device and we were searching for a repository that we could copy files from, make everything work, and then adapt it to create whatever we want to see on the display itself. There are tons of the projects. If you go on Reddit or do a search on the internet, you will find a bunch of them. For example, this one here. It showcased the device standing in the portrait orientation. But I wanted to do landscape. This project had more or less everything I want to have in my project. It was a couple of room temperatures, location, and a weather forecast for next couple of days. One thing that I didn't need is the media information or the information what is currently playing and is the media player playing, stopped or in pause mode. So that's why I tweaked it. And for tweaking, I was looking at this project here, which unfortunately, when I tried to use it, didn't work. I did figure out later on what was the issue, but since I started working on the previous project, I just copied and pasted the information from this project to the other project that I was already working on. All the links to all the repositories will be in the video description. And also there will be a link to my GitHub repository where there is an issue created just for this project and where you can see the different stages of me working with that project and what I changed and what is left from the original projects. There are a couple of ways on how you can add a new project to the ESPHome. One way is to click on New Device and then commission the device via the standard method of commissioning the new devices. There is also another different option that I prefer, and that is to create YAML file, work on the YAML file, and then have it imported inside ESPHome. And inside ESPHome subfolder, I created a file called T5. Once again, don't worry, even if you do not see the text on the screen, I would recommend that you go to the GitHub repository and pull that YAML file from there. It will be much easier for you to copy everything inside your system. But before we start digging at the code, which I will be doing through the ESPHome interface, let's look at some other prerequisites. And don't worry, once again, this T5 YAML file, plus the next, which is common.h file, and the Google Sans Bold, Google Sans Medium, and Material Design Icons font will all be linked into the video description. When you are copying information for this project, copy from my repository this T5 and command.h file. These are the files that I am working on and that can change through the time. The links for the Google Sans Bold, Google Sans Medium and material design icons will be in the repository itself, and you do not need to pull those from the video description. You can use the links from the inside of t5.yaml file. Command.h is a file where we declare some variables and information that will be later on used by the display itself, such as, for example, this month's information, which are the abbreviations for the months, and you can translate them to your local language. Same goes for the weekdays from Sunday to Saturday, Monday to Sunday, okay, and also the information about the icons. The icons or codes, Unicodes that we will be using for the icons themselves are from this material design icons file, but I will also be leaving a link to the web page where you can check each and every one of those icons. For example, if we copy this F0594, go to material design page, press F to search. This is the icon that is referenced from the command.h file itself. You can of course change and customize this according to your needs. Okay, let's presume that you now have ESPHome installed, board ready, and that you did copy command.h and this t5.yaml file. If we open that file inside the ESPHome, it should look something similar like this. The first part of the file are substitutions. Here we define some data that is specific to this device. For example, ESP name, then host name, which is ESP-dashboard. Then I also defined my fixed network IP address, gateway and net mask. Then, depending on if you want to run this device out of battery power or via the USB-C cable, we are using runtime and sleep time. Runtime is used to define how long will the device be in the wake state. Wake state is when the device wakes up, connects to the Wi-Fi network, boots up, loads up everything, pulls the information from Home Assistant, pushes the information to Home Assistant, and then goes to sleep. In my case, for every 1 minute of runtime, I have 20 minutes of sleep. And while we are talking about that, let's talk about batteries. I tested this project with this small lithium-ion battery. This is 800 mAh battery, so not that much. Others have used 18650, 2000 or even 3000 mAh batteries. In my case, if I don't use sleep and I power the device via this battery, it runs for roughly 10, 11, maybe 12 hours. Deep sleep or sleep option inside ESPHome allows the device to go to sleep, and then it minimizes the power it needs to keep the device running. That way, you can prolong the lifetime of the battery or lifetime of device on one battery charge from 10, 11, 12 hours up to, in my case, 11 days. Of course, if I would be using battery with a bigger capacity, I could prolong that, for example, to 1 month, month and a half, maybe even 2 months. Next method you can use to prolong the battery life, of course, is to extend this from 20 minutes to 30 or maybe 40 minutes. But be careful, as I am pulling here information about the calendar. I do not want to miss the calendar events, so don't put device in sleep for 2 hours if you have meetings every half an hour or 45 minutes. One thing that I have read but never tried myself is to create a deep sleep during the night. So for example, the last update is at 11 p.m. and the first morning update is at around 6 or 7 a.m. That way, we would not be updating device during the night, which of course extends the life on one charge. Next, we define the name, which is dashboard, and we include this command.h file. As I mentioned, this command.h file is used to create translations or variables for our device. Next part of the code, ESP32, is the standard one, and this defines the type of the board inside the display. We are enabling logger and we are using API with the encryption key, which is a mandatory since 1 or 2 months ago. I did mention that we are using external components. external components allows Home Assistant to know what and how to work with this display. There are various external components that work with this display. I have tried and tested this one here, and this one worked great for me. With one note, and I'll talk about that one important note a little bit later down the road. But you also have option to use either this, or this component here. This component defines two variables or two categories. One is the display and the other one is battery. And now it's good time to come back to the problem with this component. This part here, the battery part, is not working for me. If I uncomment sections in regard to the battery state, such as percentage and voltage, and flash the firmware on the board itself goes into the boot loop. If I disable and comment out those sections, it works nicely. So although I can use the display, I unfortunately cannot get the battery state and battery information, either pulled as an entity inside Home Assistant or displayed on screen. If you are going to power the device via the battery, this code here is used for that. If not, you can remove it and you will not be needing it. But also note, if you do use deep sleep, we also define pin GPIO 39 as a pin or button that you can wake your device from deep sleep. And it's great because you can then force the update on the screen, or if you're doing over-the-air update, you can use that button to wake the device up and push the update over the Wi-Fi network. So you don't have to use USB cable. Once again, next couple of lines are standard. We define over-the-air updates, Wi-Fi network with the fallback hotspot. We also enable internal web server. And now comes the fun part when we start pulling the variables from Home Assistant, or we will be pulling variables from Home Assistant and preparing them for display on this device. We start with the information about the sun. Then we are using time and we are pulling time information from Home Assistant to sync the clock inside this display with the clock of Home Assistant. And when this time sync is done, we then update sunrise and sunset components. Next, we are using this script which has ID all data receive, and this script is invoked in couple of places where we read values from Home Assistant to update the display. Note that this part for the battery voltage and battery state is disabled, and that's because of that boot loop. Next, we are defining all of the sensors that we will be pulling from Home Assistant. Each of these sensors represents a value that will be displayed on screen. For example, current temperature outside, then the minimum, maximum temperatures for the next 3 days, plus of course all the other temperature and humidity sensors that we will be displaying on screen. Next part of the code is disabled. As I mentioned a couple of times already, if I enable this part of the code, unfortunately the board goes into the boot loop. After sensors, we have binary sensors. Once again, we have this GPIO 32, which is a button, and we can see the state and capture the state of the button inside our Home Assistant, plus two binary sensors that I've created. One is tracking if the outside temperature is falling, and the other one is tracking if the outside temperature is rising. And based on that, I show either downwards or upwards pointing arrow to know how the trend of the temperature is. You can of course find links also to those two sensors inside my GitHub repository. Last but not least, we are creating some text sensors. We are pulling information from Sun and the Moon platform, and there are also some old sensors that are not used in my system, but maybe if your weather service does provide the data, you can populate it with these sensors here. What I'm most proud of is this calendar section. Here I'm pulling states from two calendars. One is a Catholic holiday calendar that is showing me what is the saint patron of the day, and the second calendar I'm pulling is this calendar Zeta with the name of the event and the time of the next event. Of course, also updating the screen. You can use whatever calendar you have integrated inside your Home Assistant. It can be either internal or in this case it's a Google Calendar. And last states or last sensors we are pulling are those device trackers. Each of the two device trackers has additional sensor, and that is a distance sensor. Don't worry, this distance sensor is also included into the repository. First one tells this device if the device is at home or not. And if device is not at home, we are then pulling the state of that second. And that second sensor is showing us the distance of that device or person from home. Next part is used to define fonts for specific texts on the display. We are using, as I mentioned previously, two fonts. One is Google Sans Medium and the other one is Google Sans Bold. And you define here the size of each of those fonts. We have small, medium, medium bold, big, large, extra large, bold. Besides those fonts, we are also using Material Design Icons -Web Font TTF, and this font is used for all of the icons or graphics on this display. Each of the icons that you use or you will be using in display, you have to declare it here. Last part of the code is even more complex, and I really would recommend that you start with the code as is, fill in the sensor data from your setup, and see how it goes. Later on, you can try and work on the display, but unfortunately, so far as I know, and if you do know an easier way, there is no easy way in ESPHome to declare or create or design the screen where the icons and text will be. So each of the locations for each of the fonts and each of the letters or words needs to be defined in pixels. First part you can leave as is. Rest of it is declarations. Screen size, center, how everything is drawn, where everything is located. For example, this section covers the date section of the screen, calendar section of the screen, weather section of the screen, room information for those 4 rooms. Then we have location information, forecast on the right side, thunder probability, which is part of the forecast, and the footer that is actually disabled or commented out and not used. Yes, unfortunately, this is also part where it should display the battery percentage and battery state, but alas, unfortunately, it doesn't work. For the purpose of this video, I myself will be hooking up this display with a USB-C cable. And I have secure connection or I have HTTPS certificate installed, so I can do everything from the UI. If not, you can compile and download the firmware and install it via the ESPHome Flasher, a command line tool, or using the ESPHome web installer. Let's press on install. I will be using plug into this computer. The device itself was plugged in. I will select the port 10 in my case, press connect. And you will probably see a screen like this. It means that it is trying to communicate, but it cannot communicate with the board. What you have to do is you have to press this button here and then click and release the button next to it. Preparation and installation of the firmware depends on the speed of your system. It can take from around a couple of seconds to a couple of minutes. Just sit tight. And we are nearly done. The firmware is now uploaded to the board, but unfortunately at this point still we are not done. There is one simple step that we need to do, and that is to add this device to our Home Assistant. Until we do that, we will not be able to pull any information and present anything on the screen. So this last step is also mandatory. But if everything went well, you will see the notification that the new device has been discovered. And that will help you add this device to your instance. Click on Notifications, Show New Devices, and just click on Configure. If your device is not visible here, the thing you have to do is press on plus sign, Add Integration, type ESPHome, select, and add another instance of ESPHome. It will ask you for the IP address. If you are running your device on the battery and you click on Configure, and nothing happens when you click Submit, it means that the device itself is in the deep sleep. If device is in the deep sleep, what you can do is either wake it up or unplug it and plug it once again. If you are running it on the battery, unplugging and plugging will not help. You will have to press the button to wake it up on the display itself. Inside ESPHome, you should see 2 new sensors, or 1 sensor and 1 diagnostic information. We have Lilygo T5 button information, and this is the information if the button on the board has been pressed or not, for example, to wake the device up. And the second is information if the firmware that is on the board is current, meaning that you have the latest ESPHome installed and that the latest version of the firmware was compiled and uploaded to the device itself. And now we are done. You can print or assemble the case, insert the battery, charge the battery because the device itself does charge the batteries, and you are good to go. I really would like to see what you have done with this T5 display from the Lilygo. If you have created something, don't forget to either drop me a link down below or tag me on the Twitter and show me what you have done with this wonderful little display. Also remember, any contributions you can do for the community is great. So if you have a good code for this display, share it with us on the GitHub and post the link somewhere, either on the Twitter, in the comment section below, or post it on my Discord server. If you did like this video, don't forget to click a like button. It really means a lot and it helps with those funny YouTube algorithms. And while you are already there, check that you are already subscribed, if not subscribed, and click on that bell button so you receive notifications where I push my next video. Also, if you can, join me on my streams, because I will try in the future to work on more projects. Last weekend on the stream we played with the Sonoff iHost and also upcoming Sonoff TX Ultimate Switch. Who knows what we will do on the next stream. And I also want to thank all those wonderful people that are supporting me and that have become YouTube channel members. Thank you all for all of your support. But also, let's not forget each and every one of you who has watched, liked or subscribed to my channel. If you too want to support the channel, you can do so by clicking the join button down below and becoming a YouTube channel member for only €2 or $2 per month. But you can also go to my merchandise store and buy something there. And no, we don't call it merch because we are adults. I will be seeing you next time. Until then, bye bye and have fun.